We're going to investigate the angles of polygons in this video. Let's begin from the smallest polygon, which is a triangle. If we have a triangle ABC here with interior angles x, y, and z, then we have a special theorem which is called the sum of interior angles. That means if you add all the angles inside, like x plus y plus z, then the result is 180 degrees. We know 180 degrees make a straight line angle like that. Now I'm going to prove this using simple geometric representation, and you can even do this at home with a piece of paper. Just cut any random triangle, and then you can do it like this. So here's a copy of this triangle, and I tore this triangle here, the second triangle, and what I'm going to do is I will separate, I will detach the each angle here, alright, and then going to detach the y, but in such a way that I'll put them together. Okay, so just take a little bit of patience. You can do this using a piece of paper at home. Okay, can put them together, attach them together. There we go. And we have the last angle here, which is angle Z. Now notice that I simply added all the three angles, which are angles X, Y, and Z. And if you observe, I form a straight line. That means the total angle XYZ is equal to straight line. You can even do this with any random triangles. Hence, the theorem of sum of interior angles is equal to 180 degrees is proven using this simple geometric representation, or using simple experiment like this that you can do at home. Now let's move now to the next. Let's investigate the other polygons. With this one, triangle has 3 sides. Let's move on to higher number of sides. Let's start from the quadrilateral polygon. So quadrilateral polygon is a polygon that has 4 sides. Okay, let's draw quadrilateral here. Okay, we have to make sure that this is random. Okay, it could be any quadrilateral, a polygon with 4 sides. Now, in this quadrilateral, we have like how many interior angles? We have 4 interior angles in quadrilateral. And the question is, what is the sum of the interior angles of the quadrilateral? So the idea is simply using the sum of the interior angles of the triangle. How do we do that? We just simply divide the quadrilateral into 2 parts. That makes 2 triangles. So we have triangle 1 here and triangle 2 here. And we know that the sum of the interior angle of this triangle is 180 degrees. And this triangle number 2 is also 180 degrees. So that means polygon quadrilateral, which has a side n equals 4 to 180 degrees angle. So that makes 360 degrees, the total of 360 degrees. Let's move on now to pentagon. Okay, polygon with 5 sides. So let's draw random pentagon here. That so it has 5 sides. That now we have the angles here. Okay, we have 5 angles. All in all. So we still do the same idea, like we divide this into triangles, and of course we make three triangles out from it. 1, 2, 3. So there are three triangles. So therefore, if one triangle is 180 degrees, okay, this is 180 degrees, the sum of their angles of this triangle, and this one is also 180 degrees, and this one makes 180 degrees. So therefore, the okay for this for n equals to 5 sides, we have uh, 3 180 degrees and 3 180 degrees, that makes 540 degrees. Okay, we can continue into hexagon, say like that. Okay, say this is completely, let's say completely random hexagon. Okay, then we have 1 2 3 4 5 6. Okay, we have 6 interior angles there, and we can divide this into triangles. Okay, there you go. So we have triangle 1, triangle 2, triangle 3, triangle 4, and we have 4 180 degrees. So 4 180 degrees for its sum of interior angles. And 4 of 180 degrees, that is 720 degrees. Okay, now of course, this is hexagon. The number of sides is 6. Now you see the relationship of the sides and the coefficient and the factor here that we multiply to 180 degrees. Here we have 4, and the factor that we multiply is 2. Here we have 5, the factor we multiply is 3. Here we have 6, the factor we multiply is 4. So these factors here, they're just simply the number of sides minus 2, right? 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4. In other words, the formula for finding the sum of interior angles of any polygon is equal to n minus 2 times 180 degrees. So this is the sum of interior angles of any polygons. This is the formula for any n, or for n gone. Okay, we have now this working formula. So for example, if you want to find the sum of their angles of 10, if you have n equals 10, this is decagon because it has 10 sides. Using the formula, 10 minus 2 times 180 degrees, and this is 8 times 180 degrees. Okay, what is this equal to? Let's get it. 0, 4, carry 6, 144 degrees. So that's the total angle of the decagon. Moving now to the overall table of the interior angles. Okay, this is I got from the Math Monks. It doesn't matter if it's regular or irregular polygon, the sum of their angle is the same. Okay, we have triangles 180 degrees, the quadrilateral is 360, pentagons 540, 720 for hexagon, and so on and so forth. Now, if we talk about what's this regular polygons, then we can have the angle of each interior angle. So we can find it. This one is irregular. Okay, this is irregular polygon. Okay. Regular means all the sides are equal. So this is regular. In fact, this is a hexagon specifically. All right, now let's what's this? Focus here in the regular hexagon because we want to find the angle of each interior angle. So we have the sum of the interior angle, which is given by, since the n here is equal to 6, so therefore we have 6 minus 2 times 180 degrees. So this is the sum of the interior angles. Now if you want to find each angle or interior angle, then you just simply divide this one. Okay, it's equal to 4 times 180 degrees. You just simply divide our S by N. So the total or the sum of these angles divided by the number of the interior angles is just simply equal to each interior angle. Okay, that's 720. Okay, it's over here. The hexagon is 720. And then we divide it by the number of sides, or n. Okay, and 72 divided by 6, that's 1, carry the 1 here, 12, that's 2, 0 divided 6, that's 120 degrees. This is only for the regular polygons. Now, I want to show another special theorem here about the sum of the exterior angles of a polygon. And this is quite interesting because if we have this as our interior angle, say for example this is angle 1, angle 2, angle 3, angle 4, okay, and angle 5, then angle 1, measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 plus measure of angle 5 is equal to 360 degrees. Now no matter what the polygon is, if you add all its interior angles, then it's equal to 360 degrees. We're going to prove it geometrically. Okay, I'm going to change the color to this one. Okay, I copied the angles here, each angle. Okay, I'm going to arrange them in this manner without changing the angle. Okay, and I put this angle here and connect the initial point of them. This one here, connect it. And this one here, connect it. Okay, and the last one will connect it. So it's pretty obvious the way we see it. No matter what the exterior angle is, it will simply form a complete circle. There you go. This angle, say what angle is this? This is angle 1, and this is angle 2. This is angle 3, and this is angle 4, and this is angle 5, and that gives the total of 360 degrees. That is because that is one complete revolution.